Welcome back, and good to see you again. Let's keep going, and let's talk about what's called complex redox equations. Now, understand that everything that we've seen before have been redox equations, but you could probably refer to them as simple redox equations. We have this idea called complex redox equations that are a little trickier, and they just take a lot more steps to balance. Now, I'm going to preface this by saying some people find this to be challenging, but I don't think this is very challenging. I just think it takes practice. So if we take some time and learn the rules on how to do this, I think you'll realize that it's actually pretty easy. I think it's one of those things that's not hard work, it's just wrist work. We just have to kind of work through it. But as long as you follow the steps, I think you'll be all right. So let's dive in. Understand that whenever we're writing a balanced chemical equation, whether it's redox or not redox, we always have to have mass balance, and we always have to have charge balance. In the past, charge was never that big of a deal. Mostly just because we were balancing with all neutral things that weren't ions. But in redox, lots of things have lots of charges. So we have to make sure that charge is also balanced along with mass. Now, understand that complex redox are complicated. So there are rules. And the rules are more like steps. And what I'm going to do is I'm just going to talk through the rules. And they're not really going to make a lot of sense. But then I'm going to show you how the rules apply to a problem. And I'm going to kind of bounce back and forth. So please excuse me if I kind of go on a little bit here, because this isn't going to make a lot of sense. But as soon as I get to the practice and come back to the rules, I think you'll start to see why the rules exist. So let's go ahead and try it. Here's the things that we're going to do. We're going to have ourselves a redox equation, and we're going to run through these steps. The first thing that we're going to do is we're going to identify who's being oxidized and who's being reduced. And then we're going to separate them into two half reactions, like we always have. And now that we have a little bit of knowledge about oxidation numbers, it actually gets really easy. If an oxidation number goes up, it's oxidized. If an oxidation number goes down, it's reduced. Usually in this class, something else is being oxidized or reduced. H or O are not being oxidized or reduced. Doesn't mean that they can't be. It's just that in this class, we are not usually going to focus on H or O for oxidation or reduction. The first thing we're going to do is we're going to balance the number of atoms of everything on both sides. So this is mass. We're going to make sure that everybody has the same number of things. If I have 2 chromiums on one side, I want to make sure I have 2 chromiums on the other side. We balance out the mass. Next thing we're going to do, if there's oxygens present in either one of our equations, we are going to balance out those oxygens by adding water to it. I like to say, throw a little water on it. We start throwing water on it, and that helps us balance out the oxygens. We throw the whole water, not just O minus or just OH or whatever. We do a whole water molecule, equal to the number of oxygens that we need. Once we have all those water molecules, adding the water gives us too many H's. So in order to balance the H's, we add H pluses to the side that didn't have water. So you add water to one side and H plus to the other. Usually double the amount because, for every 2 waters you have, for every 1 water you have 2 H pluses. It'll work out. You'll see what I mean. After we do all this, we throw the water on it, we throw the H plus on it, then we go back and we add electrons. We add electrons in order to balance charge. So the H pluses are going to bring in a positive charge. There's probably already going to be some charge in there. So we add electrons in order to make the charges equal. Now remember, we don't want the charges to be 0. We just want the charge to be equal. And the electrons serve as a way to do that. Okay. Then we combine the half reactions after multiplying them in order to cancel the electrons out. We will get back to number 7. I will come back to this. But if it's a basic solution, we just have one more extra step. Most solutions are acidic unless they say they are not. So assume, unless told, that it's an acidic solution, And then if it says it's basic, you just have one more extra step where you have to cancel out the H pluses. But after you're done, after the whole thing, you just have to double check your mass and your charge. If everything looks good, then you're done. And it should work out. It's one of those things that it's nice and easy. It's going to fall right into place. But if you made a mistake, sometimes it's easier just to start over. There's a lot of moving parts here. And I know that you'll think, oh, it's too much work to start all the way over. But it's also going to be a lot of work to try and pinpoint the one place that you went wrong. You're not going to mess up, though, because this is really easy once you get into the practice of it. But if you do mess up, then just wipe it and start it again. All right. Let's look at a practice example, and I'm going to, like I said, bounce back and forth between the notes and the practice so you can really understand where the rules come into play. I'm going to try my best to color code as best I can. So we have, let's see, we have Cr2O7. This says that these are from the book, but they're actually kind of different than the ones from the book. So just write the things that I have. And this is Cr plus 3 plus I2. Now, before we get started, maybe we can do a little practice review of the previous video that we watched. Why don't we try and find the oxidation numbers for Cr, for I, for Cr plus 3, and for I. Give it a second, and then we can use that as a way to kind of go forward. So go ahead and pause and figure out the oxidation numbers. I'll wait. Did you pause? I'm going to assume that you did. Okay, so you should have found that the oxidation number for the chromium is plus 6. Each of them have a plus 6. The oxidation number for the iodine is a minus 1. This one is a 3, and this one's a 0. So if my chromium is going from plus 6 to plus 3, then that means my chromium is the thing being oxidized. So I'm going to write that like this. Cr, I said oxidized, didn't I? Chromium's the thing being reduced. I thought that with so much confidence too. I was like, oxidized. All right, so it's the thing being reduced. And if I'm talking about I minus to I2, it is the thing being oxidized, right? Because the oxidation number is increasing. I'm going to do this in, I got to figure out a different color here. Let's do this one in purple. Okay, so I minus to I2. All right, so now let's just run through the steps. Step 1 is balance the mass, okay? So I'm going to do that by adding coefficients to the front of anything that's not balanced. I'm going to start with chromium first. Take them one step at a time, right? So let's start with chromium first. I have 2 chromiums on the left, so I need 2 chromiums on the right, just like that. I've balanced it, right? Easy as that. Let's do all of our balancing in, let's do it in red. So I've balanced it now. I have 2 chromiums on each side. Now, if I have any oxygens, which I do, if you notice there, I have oxygens right there. If I have oxygens, then I need to add water to it. And that's exactly what I'm going to do. I'm going to add water to the right side to balance out the oxygens on the left. How many oxygens do I have? Well, I have 7. So I'm going to add 7 waters to the right. Okay, that's done. Next step, I'm going to add hydrogens to the opposite side to balance out the hydrogens in the water. How many hydrogens do I have from the water? I have 14. So I'm going to add 14 hydrogens. Ooh, excuse me. Ooh, well, excuse you. I add 14 hydrogens to the left. Okay, so now that I have everything where it wants to be, now I'm going to balance charge. And I'm going to do charge in, let's do red. So let's count up the charge first before we even move. What's the charge on the left side? Let's see, I have 14 plus, and I have 1 minus 2. So that means that should be plus 12. I have a total of plus 12 charge on the left, and on the right, I have a total of plus 6. So I want to bring them equal, and remember, the only thing I can add are electrons. I know from before that chromium is being reduced, so that means that my electrons have to go on the left. That's where they go when you're being reduced. So that means I'm going to add 6 electrons on the left in order to bring the plus 12, oh, excuse me, I'm wandering here, bring the plus 12 down to a plus 6. Okay, that one's done. Let's look at the bottom one. I2. I don't have any oxygens, so that's easy. I don't have any H pluses, so the only thing I really need to do is balance out the mass first, right? So I have a 2 here. And now I'm going to look at the charge. So on this side I have a total of minus 2, and on this side I have a 0. So that means I'm going to add 2 electrons on this side, and now I am balanced. I just noticed that I did that in the wrong color. Ba-boom. Okay, so here we are, and we're almost done. Now we just have to make sure that we balance out the mass, and now we just have to balance out the electrons, and we're all good to go. So let's see. You could potentially, I guess, put like a parentheses around like this and do like times 3, but I think it gets a little messy. So what I do is I just kind of cross stuff out and I put what I do. So I know I'm multiplying this whole side by 3. So I'm multiplying this whole side by 3, and this is what I get. And then I go back and I cancel out everything else. So the electrons cancel, these cancel, and now I'm just going to add everything up. So you get 14 plus, or H plus plus Cr2O7 minus 2 plus 6I minus, and that gives us 2Cr plus 3 plus 7H2O plus 3I2. And just like that, we balanced it. And you got to check it. So if you don't believe me, which you shouldn't believe me, take a second and check it. You would count out the charges. You would notice that on the left we have 6 total as far as charge. You notice on the right we have 6 total. And that would be that. So we would have them both nice and balanced. Now this is it. That's the whole process. Like I said, you just run through the same process every time. Balance the mass, throw a little water on it, balance the H+, electrons, multiply, smush. It's easy. You just got to practice it. Why don't we try? How about you try this one? Why don't you try out, let me write you an equation and then you give this one a go. So MnO4 minus plus H2SO3. And this one gives us Mn plus 2 and HSO4 minus. Now this one's going to be a little trickier because you're going to have oxygens in both equations. So there's going to be lots of canceling being done here. But pause, give this a try, be patient with yourself, flip back and look at the rules if you get confused. Give it a shot, come on back when you're done. Okay, let's break our explanation down into a couple parts. So first things first, I balanced the mass of both. The mass was fine for each at the beginning, but then I had to add waters to both because both had oxygens. This is where it's tricky. Be careful when you have something like H2SO3 and HSO4. Both already have sources of oxygen, so you just need to add the difference between the two. So HSO3 has 3 oxygens, HSO4 has 4 oxygens, so I only needed to add 1 water initially to the bottom equation. Balance out the hydrogens, balance out the electrons, and this is when you get to start canceling stuff out. So the 5 waters go away completely, and that knocks our 8 waters down to 3 waters. And then our 15 hydrogens down here go away completely, and it knocks our 16 waters up at the top down to 1. So then the electrons cancel completely, and that's how I got my bottom equation. So double check to make sure that everything is in order. Again, it just comes down to practice. If you made a mistake, maybe go back and see if you can run through it again and where you could have fixed that mistake. Now I got one more practice problem for you. Let's try that one. Let's try this. So now we're saying that this is happening in a basic solution. Now, before you get all nervous, like, oh geez, I don't know how to do it in a basic solution, that has an extra step. Just run through it the way that you always did. Take it from the top, like we have done the other two. Go all the way to the end, and then I'll show you the last little step that you have to do to make sure that this is a basic solution. So try it like you know how to do it. Come on back when you get down to the bottom, and we will finish it together. Okay, so hopefully this is what you got. We balance out the manganese at the top by adding waters first, then we add the H+. We have to multiply the whole thing by 2 in order to balance out the electrons in the bottom equation, which we have 2 electrons on the bottom, 3 electrons on the top. Multiply them all, it all works out. So we should have this total complex redox equation at the bottom. But remember, this is in a basic solution. And it doesn't really make sense for a basic solution to have H+ ions in solution. Remember that basic solutions usually have OH-. So we have to fix this. If you look back at that number 7 in the rules, let's go back and look. It says if the solution is basic, add as many OH- and H+ that are present to equations to both sides of the equation. So we are going to add OH- to both sides of the equation. I feel like the wording on that is it's like a misprint. It's almost like it's a typo or something. What we're going to be doing is we're going to be adding OH-. Let me show you what I mean. So how many OH or how many H pluses do we have on the left? We have 8. So that means we are going to add 8 OH minuses. And when we add 8 OH minuses, so plus 8 OH minuses, those H pluses and OH minuses are going to make 8 H2Os. We also added 8 OH minuses on this side. And now that we have 8 H2Os, those are going to cancel with the rest of our waters. So now we only have 4 H2Os. So then all we have to do is write it one more time. H2O plus 2MnO4 plus 6Br minus and 2MnO2 plus no more water on this side, it's gone. But there is the OH minus. And see, we have now taken our solution, and it used to be acidic, now it is quite basic. So that's it, that's all we have to do. If it's basic, we just add OH minuses until the H pluses go away, and then cancel out the waters. It's not that hard of a step, it's just one little thing you have to remember. And that's it, that's complex redox. I understand that all at once within this nice little 15 or 7 minutes, I guess, if you're double speeding me, within the frame of this video, it seems like a lot, but I promise you that with practice, this is going to become really easy for you. You might actually like it a little bit. I think they're kind of fun once you get good at them, but you just have to practice, and we will be doing plenty of that, so look forward to it. We'll see you in the next one.